Here is the relay that we'll use to create our e-stop safety circuit. What we're going to do is we're going to use this relay to provide a switched 24 volts. And in the trainers, we have a fixed 24 volts that's there all day long. It's the yellow and gray terminal blocks. Yellow being the positive 24, gray being the 0 volts. And then we'll use this relay to take the 24 volts from the yellow blocks and give us a switched 24 volts on the orange terminal blocks. That's the color scheme. Yeah. So one thing to notice right away is this relay does have polarity for the coil, and you can see why. It is using a module here, this black module, and the module provides an indicator LED, which gives the polarity necessary. It also has a freewheeling diode here. So for those reasons, this has to be the positive terminal. A1 has to be positive 24. A2 has to be 0 volts. This is the European symbol for a resistor. So you got a current limiting resistor for your indicator LED, but the polarity comes from the indicator LED and the freewheeling diode, which is backwards, of course. I mean, otherwise it would short things out. So that's why we have polarity. And then another thing you might notice on this relay, and they call these ice cube relays as a nickname. They do sort of resemble that. There is a mechanical reset, this blue button. So, I mean, it's possible to run into a machine design where if the safety circuit's tripped, you don't have that maybe reset button on the front. They don't want that. They want you to have to go in, somebody who's, allowed to unlock the cabinet, go in and physically reset. So in that way, it sort of makes the sealing circuit resemble a circuit breaker, Things are going to get popped off if there's a short, or if power goes down, or if someone hits the panic button, the e-stop. And the only way to reset it is to reset this relay here, which does remind you, it does have the feel of a circuit breaker, doesn't it? You just push this blue tab. You can see then physically it pushes the contacts to close when I push that blue tab. Yeah. There's also a mechanical orange indicator that just shows in the window when the contacts are in the down position, when they're pulled in, and it's not there, right, when they're up. Now, why would they do that? I mean, can you think, I mean, are they just trying to be cheap? Did they not want to put a nice light there for us? Because, that seems more normal. Well, in fact, that's not the answer, because they have an indicator light that they went to the trouble to put here. Can you think what this does? Let's ask ourselves, what is this indicating, the LED? Well, if you see that yellow light, that would be indication that the relay coil, or at least very close proximity to it, is getting power. The orange tab indicates that the contacts have actually moved, because look, it's physically right along for the ride. So it's telling you about the movement of the contacts themselves. So that's one step closer to what maybe you really want to know about. Because, I mean, it's conceivable that the relay coil could have power, but somehow the contacts aren't moving. Maybe there's some kind of a weld from the normally closed, or maybe they're just jammed or somehow, but they're not moving. So this really assures you could look down the line, and if you see that orange show up in that window, yeah, it's closed. The contact's closed. So, I mean, again, just goes to the point of, in the industrial world, you ask yourself, what does the indicator indicate? And so that's why there is a slight difference between those two indications. It is a 3-pole relay. You got the clear plastic to look right through, and you can see 3 poles that are moving. And this type of relay that you actually have poles and throws. Some relays you just have standalone contacts, very similar to what we bolt onto the back of an actuator of a switch, So solenoid relays tend to just have an actuator, and it'll just actuate a plunger much the same way that those industrial switches we looked at do. But this is more of a pole and throw design, and but you can see what's there. We'll get into more details with relays. There's lots to talk about as far as other specifications. I mean, every one of those contacts has ratings. There's a certain amount of current that if you exceed it, it could weld the contacts together. It'd be too much. There's power ratings, a combination of the voltage and current. There's voltage ratings, which speak to the gap that sits between the contacts. Before voltage would be able to arc across. So there's all kinds of ratings that would go along with, choosing the appropriate relay to use. So we'll get into more of that, like the details of relays and the specs, that go along with them. We'll do that later. I do have the data sheet for this relay posted under the Files tab, and you can look that up. I've done you kind of a favor here because this one takes a little bit of tracing. I mean, the power is kind of obvious, I think, A1 and A2. And these are 2 points of connection for A2, in case you want to keep that common daisy chain down through. But then, these terminal numbers, you have to associate them back to the pin numbers of the relay, and you have to associate the pin numbers of the relay to its own schematic. So I believe you can see the pin numbers here, like pin 4 of the relay cube itself is terminal 12. Now, the other numberings have been covered up by this module here. But I've put together a key for you that you can follow. Some of the relays we'll use, they've made it really nice. They just already label things like the normally closed contact, the normally open contact, and the pole that associates with it, and they have that right out on the terminal block. Not so on this one. It's a little more cryptic. Nothing major. I mean, you just have to look at the data sheet. It's here, isn't it? I mean, but it's hard to read a little bit. But see, they're going to show you a little drawing. But it's also on the data sheet. But they'll show this to you. There's a pole. So 11 is a pole. Looks like 3. It's hard to see. And 9 is a normally open contact associated with pole that's on 11. Looks like 8's a normally closed contact that relates to the pole that's on terminal 11. So 8, 9, and 11 all are associated as far as pin numbers. But then you have to look, and if I'm right about this, but there's 8, 9, and 11. Well, we lost track of that. And it's not necessarily terminal 11. It's pin 11. So, okay. So anyway, I've associated those for you. You could do it. I know it's not a big deal, but it's there for you. I'd have to pull this apart. If you're curious, I mean, don't try to pull this module off before you get the cube out, because the cube actually holds the module on. So, all right. Why not? We've gone this far. Let's get that off of there. See how there's a tab underneath here that the cube relay was pinning down. Okay. I forget what we said, but maybe 9, 8, and 11, which is actually 11's here. Now you're kind of starting to see, you'll start to see some standard numbers that they use. So we said 9, 8, and 11 were all associated. And that means terminals 31, 32, and 34 are all associated. And I forget what the cube showed. Oh my gosh, we are, might as well get close to finishing this. 11 was the pole. And that doesn't surprise me, because a convention you'll oftentimes see is the pole might be an odd number and the throws might be even numbers. So pole 31 throws to terminals 32 and 34, or throws 32 and 34. Which one's normally open, which one's normally closed? I got to look back at the cube again. Of course, when you're wiring something like this up, my gosh, you would never keep tracing and, you know, looking at that diagram, looking at this, and then looking at this, and then getting your wire, and then crimping it, and then terminating it. No, you do what I did for you. You create a key that absolutely identifies poles and throws, and you don't have to keep looking here, because it's so easy to make a mistake if you have to keep retracing all that. It's not hard, it's just easy to lose track of something. So, okay. Let's get that back. This wire just is a thing that helps avoid the relay coming out of its base from vibration, due to vibration. So that, oh, you know, classic, right? Needed to put this in first. So I'll do that later. Well, one last thing, might as well mention it. If you are putting this on and off the DIN rail, and this goes for any device that we hook on DIN rails, make sure you understand how it's supposed to happen. So here there's a spring, so you would put this piece on the first, and then you would push up in this direction, which presses this spring down, and then that lets the DIN rail, it lets this part come over the DIN rail and slide on top of it. I'm only mentioning this because it's a little bit of a design flaw with these. These tabs are not very strong at all. And we have broken them off many times. And well, once you break these tabs, that kind of means that relay can't hang on the DIN rail anymore. So we have a graveyard of these just because those plastic tabs are a little weak. So just be careful. I don't think you have to take these on and off the DIN rail. In fact, please don't. Please leave them on for that reason, because they just break too easily. It's not a good design. They should have been a little tougher, and they're not. And in fact, that reminds me, that is probably why I went to the trouble to create that key for you, so that you don't have to do all of this. Take it off the DIN rail, take it apart, make your own key. I think I remember doing that earlier years, and then I got away from it because we were just creating a graveyard of these just because those plastic tabs on the back keep breaking. So, okay, so leave it on the DIN rail and just follow my key. I promise I didn't lead you astray. All right. So then this is the relay, though, that we'll use to build our E-stop, reset, seal-in circuit.